Hello and welcome to this session on building simpler microservices architectures for app modernization. I'm Sanjay Goyal. I'm VP of Product Management at Oracle. I work on the Oracle Database Cloud, and I've been at Oracle doing this for about 2 years. With me, I have Paul Parkinson. Paul, please introduce yourself.
Yeah, I'm Paul Parkinson. I've been at Oracle about 20 years now as the development lead in the mid-tier for transaction and data processing. So that's mostly been in WebLogic, the Helidon Microservices platform, and OCI. And I'm now a developer evangelist on the database side.
Awesome. So we're glad you're here. In the next half an hour or so, Paul and I will cover microservices, we'll cover app modernization, and we'll cover a lot of the architecture aspects to it. Paul will move the slides for me, and then after some time, Paul will start presenting the details on some of these microservices patterns we have. Paul, next slide, please. So quick overview, we'll talk about the architecture. We'll look at the Converged Database advantage, some patterns, and we'll transition to Paul at that time. And then, of course, the focus here is on the simplicity of building microservices architectures, not only on the Oracle Cloud, but on your on-premises infrastructures, or maybe on other clouds as well. And we'll also point out to the hands-on lab that we'll do after this session, which will also make all these concepts come to life in a hands-on experience for you. And of course, we'll leave some time for Q&A as well. In this session, you'll learn how to build a microservices application. And I think that's something we are really proud of to bring in this session. Next slide, please. So most developers, I think that's the previous one, Paul. Most developers want to build data-driven applications as microservices. And there's a lot of debate, are they micro, are they mini, and then are they microservices? So I take the slide from Gartner, where they talk about the continuum of what a monolith can become. Right? It could be a macroservice, it could be a mini service, it could be microservice. So again, it's semantics, but in the end, data integrity is in the monolith. All data is together. There is again some overhead in terms of moving towards microservices, and this is where complexity starts to come in. A lot of our focus is to build simpler microservices by building in the right persistence layer. Right? So you will see some examples of how we bring the Converged Database to play. We get into simplifications of not only code, DevOps, performance, availability, and security. Right? So we'll start with the definition in the next slide and go from there. Right? So when we look at microservices, what are they? Right? So I like this simple definition. It talks about loose coupling of service-oriented architecture, but with bounded context. Right? So again, a quick check when you are loose coupling. If you know too much, or every service has to be updated, then you know that it's not loosely coupled. Same thing with bounded context. If you know too much about your surrounding services, it's not bounded context. The challenges in microservices appear when you don't have the loose coupling or the bounded context, or you don't really know if you need to do tens of microservices or hundreds of them. And this is where I think going through some of the concepts will help us. Next slide. So why would you do this? Why would you build microservices? Right? You see that I think a lot of folks here would agree that monoliths have evolved to become behemoths. Right? So they're difficult to enhance and difficult to maintain. And the database schemas have evolved into unmanageable schemas. Right? So microservices hold this promise of having a limited contract, easier to enhance and maintain, and also having smaller database schemas. Right? So again, it seems simple to say these things, but when you see some of these things in action, you'll appreciate what it takes to build microservices. Next slide. This is what the complexity shows up as, right? When you talk about Lambda or Kappa architectures, again, Lambda was built on Hadoop, Kappa is around streaming everything. You see from the left side, producers of information, like web servers, order services, APIs, or even transactions in databases stream through, something like an Apache Kafka, have intermediary stores in object stores or a data lake or analytical stores, and then get consumed, right? You can see the data flow leads into many technologies, multiple data stores, copy contagion, complexity of maintenance, and finally even the skill set, because each of these will have its own language, its own storage, its own protocols. So the skill set kind of starts to get fragmented, and this is what we see a lot of folks start to implement. And our next slide talks about where some of the simplification comes in with the Converged database. So the Converged database is something we'll cover in the next couple of slides. But think about it having the variety of data types. Now, if you want to have document databases, relational databases, messaging, right? So that's kind of all the Converged database. You can still have the producers, the data and events produced into this Converged database, and consumers consume from here, right? So again, with the microservices support, we're building in the open interfaces. You'll see some of those, and the easier app building blocks and APIs that we bring to the table will help you make the architecture simpler. The autonomous database from Oracle, is also a fully managed service that makes the entire data architecture simple to procure and also to deploy. Right. Next slide. So if you're currently using special purpose databases, Postgres or Amazon Redshift or Snowflake, these data types are of the types of JSON, relational, spatial, right? So they can be consolidated, right? So again, data consolidation leads you to deeper insights, but also the convergence leads to virtualization in the container database and the pluggable database architecture that the Oracle database has. So a lot of these advantages will kind of show up as we are looking at microservices and their bounded contexts coming into deployed in their own PDBs, right? So think about the virtualization at the database layer happening with the container database that leads you to this advantage. Next slide. So a little more about the Converged database. We support any data, right? It's relational. JSON is what is referred to as document database, graph database, spatial, text, blockchain, XML. Also, any workload. So you can kind of talk about transactions, analytics, machine learning, IoT, and it's transparent with the whole idea of the PDB architecture. You can scale up and you can scale out, support sharding. And finally, there's a lot of productivity being built in, right? So some of the aspects of microservices we're going to cover, events, REST, the machine learning notebooks that come in, and of course, low code with Apex. So there are several other talks. I'm sure you must have heard about some of these technologies. All of them coming together make the microservices architecture fairly robust with the Converged database. Next slide. Now, on the right side, you see the data platform. You see the advantages of the Converged database, the convergence that we talked about of transactions, of message APIs, of the various data types. On the left, however, we're talking about the application tier, right? So application tier, of course, you can build in Java, Python, Node, but also deploying these Docker containers with Kubernetes, using service meshes, using some of these various aspects for monitoring functions. So all this kind of comes together in a stack that, again, is open, is also deployable, not only on the Oracle Cloud, but on premises and on other clouds, because some of these are open interfaces and other clouds also support them. So combining the app and the data tier together kind of brings in the entire microservices architecture in the next slide. So here you talk about your favorite app development layer at the top. You can bring in Visual Code, IntelliJ. You use your own CI/CD pipelines with Jenkins. Then you start seeing traditional applications being built with Java or WebLogic. You see microservices platforms like Micronaut, Helidon, using Graal VM. You see various language types. You see cloud events with serverless functions, right? So, a lot of this is available not only for Java, but for other languages. And then in the middle, you start seeing the entire deployment flexibility you get with Docker containers, Kubernetes, Istio that we talked about. And of course, the database layer of autonomous database, the Converged Database. However, a lot of people also want to use MySQL or Postgres in their environment. So that's supported as well. And below that, you start seeing architectures of a public cloud like the Oracle Cloud Infrastructure and its managed services, or if you want to deploy on your own in a private cloud. Now, observability and monitoring is, of course, important across all these tiers, not only at the infra level, but at the platform and the application level as well. And there's a whole set of technologies that are coming together to bring out the observability aspect. And Paul will cover some of these. And of course, the labs that we have show these in action as well. Next slide. This one highlights the collaboration, right? So, yes, we talked about the platform, we talked about the Converged Database, but when developers are developing, they want to be programming business workflows. They want to be using microservices frameworks like Spring Boot or a Micronaut or a Helidon. And of course, the data modeling aspect, right? So that's the focus of the developer. Then they collaborate with the architect who's looking at the deployment of the service mesh. Is it on a cloud? Is it on premises? Is it autonomous? Are we looking at managed services? And then the DBA at the data layer, right? Looking at the database, at the persistence layer, the Converged Database, the automation aspect. So the collaboration not only happens at the technology level, but also at the role that the developers, the architects, and the DBAs play, especially in the microservices context as you are scaling these microservices on the cloud. Next slide. So let me transition to Paul. We kind of talked about the architecture, the overlying, the overlay of what the technologies mean. Now let's dive into the microservices patterns like event sourcing and CQRS. So let me maybe have Paul cover these and give you some detail on each of these. Paul?
Yep. Thank you so much, Sanjay. So yeah, I'll be going through each of these in the following slides. We won't really have so much time to get into service mesh and data refactoring per se, but some of the core concepts we want to go over here as far as data-driven microservices are these first five. And I'll explain why, some of the anti-patterns that go along with it. So the first thing to discuss with microservices, of so many differences between a microservice environment and a monolith environment, but certainly the most obvious and maybe the most impactful is the fact that you are introducing a variable of network calls between microservices that you may not have had before. And so communication is key across these microservices. And that communication can be synchronous or asynchronous. So there's nothing that prohibits continuing to use or using synchronous communication such as REST or gRPC. And optimization has certainly been done in these areas. And you do have the ability to horizontally and vertically scale and things like that. But asynchronous communication is really a powerful fit for microservices because of these network calls, et cetera. And because you can have, again, everything with microservices is around this loose coupling. So you can have these loosely coupled components, components actually offline when you call them to that extent when you're using asynchronous communication. And it allows for, again, you can scale with synchronous. It's not, prohibited or anything like that, but it allows for, more robust quality as far as scaling and things like that. And so we're going to talk a little bit more about that asynchronous communication in the next slide as we talk about event sourcing. So in these data-driven apps, basically you want to accomplish this communication between the microservices and also manipulate data, of course. And so you have these two actions, the communication and the data manipulation. And so a pattern that's actually been mentioned, many decades back that has become a nice fit in the microservices space is event sourcing. And this is where your communication and information about data is sourced from events. And basically what it comes down to is whenever a microservice is conducting an action, it changes the data, and then an event describing the change of the data and any contextual information or whatever is sent. And any microservices that are interested in that listen for these events, and they source their data from these events instead of, say, going directly to a database or, propagating via calls and things like that. And so there are a number of different ways to go about this, but the event broker becomes the source of truth, as you might imagine, because it is, the source of these events that are constituting everything. Along with this, what works in partnership with event sourcing is the ability to use CQRS, Command Query Responsibility Segregation. And all these patterns I'm mentioning today actually are fairly old, but they've been proven, but they've also found even more of a fit in this microservice space. And so CQRS is one of them. And again, to the point of decoupling, as Sanjay brought up, it's the big part of microservices, is optimizations where you can decouple the command and the query aspects of your data interactions. So, whereas before maybe you had just straight SQL insert update, and then you're using SQL to, query the selects. Now you may have a command, which is a update of JSON data, and then a query, which is made up of the result of information received from events, such as what I was mentioning in event sourcing. And so you have this separation, and therefore you can optimize because you're not locked into this, same API or mechanism for your commands and queries. And so you see an example here, which is similar to the example in our workshop, where you can make inventory changes, but those people that are interested in the inventory changes aren't necessarily using the same query. They're listening to inventory change events to determine, what the state of data is, state of inventory. So this is where, if you may have thought of the fact that I'm talking about two actions with this event sourcing. You're talking about manipulating data and sending an event. And there are a number of different patterns that you can use, such as the outbox pattern and things like that. But at the end of the day, what's critical and advantageous is if you can make those two actions atomic. Because if you have one happen and not the other, you're in trouble in different flavors. So on your sending side, if one of those actions happened, you manipulated data, but the message didn't send, or vice versa, you may even need to have an admin come in and rectify the situation. Or you may end up sending, multiple messages because you have to read it again and things like that. On the receiving end, you may have to deal with duplicate delivery. And that's basically how these systems that don't have these transactional ACID or atomic guarantees will have to deal with it. Your microservice will need to be written in an idempotent manner. So it's keeping track of IDs in case it gets a dupe ID, it has to handle it. And this is what we're talking about with simplicity. You don't, even though they say microservices, you should write them to be idempotent, it's not as easy done as said. And so if you can have a guarantee that both of these activities are happening atomically, you don't need to worry about handling dupe delivery and all this administrative interaction if something goes wrong. And that's exactly what the Oracle AQ engine, which has been around for decades, very hardened, tested in many environments, provides. Because AQ is the same resource manager as the database, decades ago, they were able to optimize this so both the data manipulation and the message send are in the same transaction. So I spent a little time on this concept, but it's because it's very fundamental. It's the communication and data manipulation. So this AQ events that provide that, it's a very strong advantage. Now we go into an even more complex topic, which is, so you have your communication and your data manipulation. Now, what if you have multiple microservices involved in an activity or in an action, business transaction, whatever you want to call it, and they need to have data consistency, integrity between the two of them, your bank transfer, your order inventory, you're booking a trip, things like that. All the actions, you need your asset properties like you had in traditional monolith systems. The problem is actually two things. One is that it's going to become more common that you will have this situation actually, because you've split your services apart. So the chance that you're going to have this data integrity across multiple processes increases. But it also brings about the fact that patterns used in the past for these guarantees, such as XA and two-phase commit, involve distributed locking. And if you're introducing networking in these disparate systems, all the different types of microservices you can have and the places you can have them and the context and things like that, to continue to use distributed locking is prohibitive. And it's again, we don't want to be dogmatic about things. You can certainly use XA and two-phase commit in a cloud environment, and WebLogic and other systems like that have been successful. But there are barriers to taking advantage of the microservices advantages, such as scaling and deployment models and things like that. In the best case. In the worst case, it will actually introduce issues with locks being held open and things like that. So again, we look to an older pattern called the Saga pattern, which fits this need in the microservice space. And so the main difference between old systems, old transaction protocols such as XA and two-phase commit and Sagas is that in the Saga case, you're only using local transactions, so you don't have distributed locking. And a key part of it is the fact that you're now putting the onus on the developer to create compensating activities. Because in the old systems, you had the system was bookkeeping everything, and you could tell the system to roll back or commit, and it would take care of everything on the back end. Whereas now with these Sagas, each microservice has to define its compensating activity if something goes wrong. And its compensating activity needs to know, it needs to bookkeep and journal the previous state and what actions need to be taken to go into the previous state if something goes wrong with this business transaction between these multiple services. So very quickly, I'm going to go through the flow of a Saga as defined by the long-running action specification. So this is the most fully detailed Saga specification that there is now. And that's why I use it as an example, and that's why it's implemented in our Helidon microservice product. So very quickly, in this scenario, we have a travel agency and a customer is coming in to book travel. So it makes a call to the travel agency. Behind the scenes, there's an LRA library in the microservice framework in Helidon in this case. And that's calling a devoted LRA coordinator service, which is sort of like a transaction manager if you're familiar with older systems. It's saying for it to join the to start a Saga or start an LRA, and then it returns to the travel agency. The travel agency then calls a service that's going to be part of this Saga, and behind the scenes, that service is enlisted in this Saga with the LRA coordinator. This process continues for any other participants in this Saga. And then depending on whether it was possible to successfully book the hotel or the flight, the travel agency will go ahead and tell the coordinator to complete or compensate. The LRA coordinator will then call these services and tell them to issue their complete or compensate logic that they have defined. And so you can see if you're using AQ in this scenario, any one of these lines could be a break in communication that AQ is now handling. So that's the basic flow of the Saga. Now I want to go into topics that aren't directly related to transactions per se, but are very important for microservices in general and very important additionally when you're trying to use data-driven microservices where there's information. And that's this basic concept of observability and tracing. And so taking you through a basic flow, your microservice advertises metrics that you would view in Grafana. You would see in Grafana that maybe something has slowed down or there have been errors. You then go over to a Kiali console, which shows on the bottom left here, your microservices call graph. And so you can see here an order inventory LRA saga. And then you can see if there were red lines, exactly what went wrong and where. And then you can drill down to that into your open tracing, which you can view in something like this Jaeger UI in the upper right-hand corner here. And then you can really get down to the logs, tagging details, and things like that. So we mentioned this, it's works together with microservices to debug these data-driven, scenarios. This is just quickly showing a kind of spectrum of the size of microservice frameworks. These are all Java, and it's kind of large to small. And then this is an example of Helidons and microservice annotations in Helidon, and how it makes things much easier. So all of the aspects I just described are enacted or activated on the microservice just using these simple annotations. And so the last thing I want to talk about is the workshop that we've alluded to. So it's based off of a kind of an Uber Eats type model that we call Grab Dish. And in short, it shows an example of all of the concepts we've shown above, as far as the PDB per service, the event broker, the Saga event sourcing and CQRS patterns I mentioned, and all the different data types in the Converged Database. So you'll see the order in JSON, the inventory in traditional relational SQL. You'll see spatial data of the route from the delivery service to the customer and things like that. It's all shown in this workshop. And so you can see we continue to add a lot to it. You'll see the observability aspects I mentioned, but we continue to add a lot to this workshop. So we really hope that you will take it and give us feedback. And with that, Sanjay, I think I'll hand it back to you to summarize, if you would.
All right, thank you, Paul, for that whirlwind tour of technology. Yes. It makes our heads spin sometimes when we go over it so fast. However, I think it's important to understand there's a lot that goes into building successful microservice architectures, right? And I think we, in this short session, highlighted the simplicity of the Converged Oracle database. There are other sessions in this, sessions that talk about the various aspects. For details, I'm sure you can see those. The unification of data, of course, leads to deeper insight from data. And that's one of the biggest asks from data architecture these days is, how do I bring variety of data together? So hopefully you saw some flavor of that as you build your microservices. And finally, the deployment concerns of, does it work only here or there, on this cloud or that cloud? I think those are some of the open technologies that can take care of that to ensure investment protection. I hope you'll join us for this next session, which is the hands-on lab that Paul was talking about. We spent a lot of time building those, showing you these concepts in motion. If not, there's a bit.ly link, Simplify Microservices. You can access those and kind of do that hands-on lab yourselves on the Oracle Cloud. With that, I think we will end here, and perhaps there is some time for questions and answers now. So I'm seeing some questions come up. Where can we get access to the Converged Oracle database for this workshop? Can these microservices patterns be deployed on premises? Paul, do you want to take that?
Yep. So I'll start with the second question. Certainly, these microservice patterns can be deployed on premises. Yeah, definitely. All of this applies, and we focus the workshops on that aspect actually. And then you can get access to the Converged database by going through signing up for free trial. There are a number of flavors we have, but one of them is if you don't have one that you bring with you, you can sign up for the free trial. And so you get this I don't know if you saw on the infrastructure of the earlier slides, you're set up with ATP, Kubernetes, the propagation between the PDBs, OCIR, all the tracing and everything. That's set up in, within the first 15, 20 minutes of the workshop. And so again, it's really, if you go to the workshop, you will get this, great bird's eye view of everything.
Yeah, I think the link was on a previous slide. It's basically bit.ly, bit.ly, simplify microservices, right? So that's at the bottom of this slide here. So please take a note there. I think that's the time we have for Q&A. I hope you liked the session. So thanks for having us here, and thanks for your time. Goodbye.
Yep, thanks so much.